Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in this week's video we're going to do a little something I've never done before here in the Tin Barn. We're going to actually surface grind aluminum, or we're going to make a good attempt at it. What we're going to do is take my Tom Lipton chamfering block that kind of a hot item on YouTube right now. Max Grant over at Swan Valley Machine Shop has done a video on making one of these. Also, Stephen Lang at Shark River Machine has done a video on it. I know Chuck Bommarino has just got the plans and got the material to make one himself. If you recall, I made mine from aluminum. I've since gone back and done one little enhancement to it that you've not seen. I milled out a spot over here on this end to hold one of these disc washers. And the purpose of that disc washer, the little block that I made as a guide block and also a depth set block, with that magnet installed, it'll just mount right there on the side. That helps me keep up with it. I've had two little issues with this block. Number one, the primary issue is that grit sticks to it. And as I'm running a piece across there, getting chamfer on it, then if I turn it or run the next one, if I don't clean this real good, I get scratches on the surface of my workpiece. And that workpiece has normally just been surface ground, so scratches is not something I want. Max, in his video, he showed a grid pattern that he put in here and actually milled small grooves in there. The purpose being somewhere for the grit to go. The jury's still out on that, on how much difference that will make. But Stephen Lang did it himself. He did just straight lines across his. I'm going to do a combination of both today. We're going to set this up on the lathe or on the mill, and I've got some end mills, if I hadn't lost them, a 10-pack of 1/8 inch ball end mills. And the reason I got a 10-pack, I'm not sure how good a quality they are. This was 10 for less than $15. You can pretty much guess where they're made. But we're going to try them, and that's something else I've never done on my mill. We're going to run it in high range, high speed, which on it is 1700 RPMs. I'm not sure I've ever run the mill that fast, but we're going to try that with this. Now, to set this piece up in the mill, we're going to use something I built a couple videos back. I got really good response and viewership to making this two-piece mill vise. So we're going to use that. And I also got a good viewer response on making these V-block parallels to go in there. So I'm going to turn over to the mill now and start setting this up. All right, I've got my regular vise off of the mill table, and I've stoned the table to be sure there wasn't any nicks or anything. Now I'm just going to lay this up here. This is the center line of the mill table. I'm going to lay that up there and just get an approximate center. Now, a couple of things I have done to this two-piece vise since the video where I made it. I realized my socket head cap screws, when I counterbored these holes, I counterbored them so that the head come out just below being flush. But then I realized I only had about a thread and a half, if that much, catching in the T-nut. So I went back and counterbored these a little deeper as well. You might also recall in the video where I made this my lamenting and ranting over the counter bores, the pilot form not fitting in. I have since carried that set of counter bores over to the surface grinder, set it up, and ground every one of them to the clearance size for the bolt that they were made the counter bore for. Some of them were spot on, some of them, none of them were too small. They were either spot on or way too large. All right, for this job, I think it'd be perfectly fine to set it up with the square. Could easily put an indicator in the quill and indicate this in if necessary. But again, for cutting some grooves in the platen area of the chamfering device, I think this will be fine. Several viewers also suggested too in the comments that I carry this jaw back to the surface grinder and take a little bit off the bottom edge. Remember, these were all surface ground together, so they were exactly the same size. So that's what I did. I carried it over there and took about 15 thousandths off the bottom of this, just so it doesn't bind when it's trying to slide. And remember, when I made these V-block parallels, I put the indicator marks on there to keep them matched and keep those marks pointing toward each other. And by keeping these V-block parallels loose in there, it should self-align, which if you'll notice, it was cocked in there a little bit. Watch it as I tighten up, it'll pull into place. I'm just going to snug that down. Folks, I believe that's in there to stay. Just be absolutely certain it's setting down in that V-block like I expect it to. Okay, some of you are probably saying, Lee, how about running an indicator across that and let's see how close it is. Well, off camera I did, and it's about 20 thousandths out from one end to the other. But keep in mind, when I made this block, I did not have this match set of 45 degree or 90 degree parallels. I actually had this mounted on a table, something like a sine bar, but it's a rotating table. So it was a guess. I guess would be the best way to state that. But what I'm going to do now is run a fly cutter across this, and I just want to. I'm not going to take much off, just take enough to get that flat. And this is what we're going to try surface grinding afterwards, after we get our grid relief channels cut in here. So let's try this real gently. All right, I hear it hitting somewhere. Oh, I see where it's hitting. This is extended out longer on this side than the other side is. why you always test before you jump right in. All right, it's all looking good so far. Got just one little area right down here at this end. That's going to be a total of about 18 thousandths once I get that, it looks like. Think we'll get it on this pass this time. All right, I'm assured now that's a good flat surface. And the only thing this is doing to the block, as far as the guide, is making this little gap in here just a little larger. I'm going to put an end mill in now and run it down this edge as well, just to be sure that it's square to the new surface we just cut. All right, I'm going to try 10 thousandths and see what that does. See if that cleans it up. Cleaning it up to start with. All right, I may have to come back in here and clean up my my relief on each end here, but I can do that after we finish cutting the grid in here. I can lay this down flat and just run an end mill through it. Okay, I got the grinding slots or the clearance slots cleaned out enough for now. As I say, when we get done with this, we'll lay it flat and clean those out. But what I've done is come 1/4 inch off of this back side and set my zero, my DRO. And I also located center here. I'm going to put a 1/2 inch grid in this, or grid lines on a 1/2 inch. So I want to come over 1.5 inches this side of zero. There's my zero on Y, which again is 1/4 inch off this edge. And again, I'm going to come 1.5 inches off, 1.5 inches from center. I'm sorry, that's 2.5 inches off of center. Well, I'll get my ducks in a row in a minute. It's 3 inches off center. Change my mental note here. It's 3 inches each side of center. And I'm going to touch off, and here's where we're going to go to everything this mill has as far as speed is concerned. I want to be sure I got clearance under here as well. So there is 0. Now I think I'm going to come down about 20 thousandths. There's 3 inches. Now we're going to step a 1/2 inch back. And we'll go to 3 inches on this side of center in the other direction. So far that little, what, $1.50 end mill, I think it was 10 of them, I believe it was about $15, that $1.50 a piece. So far it seems to be working real well. Remember, the grooves they're putting in here is just somewhere for the grit to brush into or fall into. And if I hadn't already promised you we were going to surface grind this, I'm not sure that I would anyhow, because I was expecting that to leave a burr, but the fly cutter and then running this in there seems to be leaving a good finish. But unless I change my mind, we are going to surface grind it. I think it'd be an ideal piece to test surface grinding aluminum on. Step back another 1/2 inch. All right, while I'm right here, instead of stepping over now for this last one on the y-axis, I'm going to go ahead and clean up this end one, and that goes from back down to 0. Half, 1, and now 1.5. All right, so now we'll put our end cut down here at this end as well. Finish it out. All right, now what I'm going to do, I'm going to step 1/2 inch at a time on the x-axis to move all the way down to this end. And I won't bore you with doing all that, but I'll bring you back before I take it out of the jig and show you what the grid pattern looks like. All right, here's a quick shot of the pattern we've just milled in. I'm extremely pleased with that. That's same cutter, went all the way. Of course, as you can see, I wasn't pushing it real hard. What I'm going to do now is set this up flat. I'm going to take these 45 parallels or 90-degree parallels out from under it, set it up flat, and clean out the relief groove in the bottom of the V. All right, I'm over at the surface grinder now, and we're about ready to do what I promised you at the beginning of this video that we're going to. We're going to try surface grinding aluminum. As I told you earlier, this is the first time I've ever done this. I am by no means an expert on surface grinding aluminum, nor am I an expert on surface grinding anything. But I got on YouTube and I watched a few videos, read some comments on surface grinding aluminum. And there was a video by the guys over at Solid Rock. I'll try to put a card to them up here. But he did a video on grinding aluminum and was not having the success he was really expecting to. And in one of the comments, Robin Renzetti posted a comment to that. And you know, after a while watching YouTube, you kind of get a feel of who you can trust and who you can't. Some of the channels I watch them just for pure entertainment. Others, I trust every word they say. But Robin suggested using a silicone carbide 36C or 39C grinding wheel. I'll show you a picture right here of his actual comment. In that comment, he also said use a high mineral oil content coolant. Now, I'm not sure what the ingredients are in my coolant, but I'm going to flood it. I want to open the cool it up all the way on here, keep it plenty moist. The idea is not to get built up in your surface wheel. This is a Norton 39C silicon carbide. It's green in color. Here's an image of the McMaster car order where I ordered this. I think it was about $60 plus tax and freight. So that's what I'm going to use to do the grinding, or the attempt to do the grinding. I promise you guys this is the first time I've ever tried to grind any aluminum. Now what I've done as far as how to hold it in the vise here, this is of course a mag vise. I want to hold this at 45 degrees. It does have a steel base on it, but that would be at 90 degrees. I first set my two-piece vise up here on this magnetic vise and said, well, I'll just set that up there. It's got enough of a surface on it that the mag chuck will hold it down. Well, the last inch or so on these mag chucks, there's really not much magnetism at all out there. You can see there's really nothing right there, where in just a little ways is where the magnetism starts. So what I ran into was setting that up here. I was at the edge, pretty much at the edge, and when I put my 90-degree parallels in here, the magnetic holding was not as strong as the screw where I was trying to tighten down and wedge it in. So I took that two-piece vise out and just set it up with these magnetic transfer blocks. They work extremely well. I got lucky and got a set of these two rectangular ones and two V blocks. Found them on eBay a year or so ago at a very reasonable price. But I've got them set up in there now, and it really is holding my workpiece. I could jerk it out, but what it's holding is on the magnetic transfer on this side, on the steel plate, and just wedged in. So I've got down here on my dial, off camera below here, on my Z-axis dial, I've got a 0 set so I don't crash in to this edge. And I'm right ready to touch off now. Matter of fact, I may be just about touching. Be sure that's down seated good. All right. So we're going to see where this goes. It may sling it off the end down here. I don't think so, but we're going to give it a try. And the whole purpose of this was to clean up that original end mill surface I had. As I said over there on the mill, if I'd known that fly cutter was going to clean it up that good, and the ball end mills not leave any more of a burr than they did, I probably wouldn't even have planned to do this. But we're going to see how it turns out. I'm just going to ease down. There's 2 thousandths. I just want to see if I'm going to touch anywhere first. I keep doing a couple thousandths at a time. And obviously we're not going to see sparks here. I'm not really sure what kind of indication I'll get. Still haven't touched yet. We'll stop it right there and try easing it down by hand. I may have left a little bit too much there. All right, let's try that. Let's get the coolant going. Should have had that coolant pump primed as well. Here we go. Not sure if you can hear that, but it's just barely touching now. All right, we're going to come down 1 thousandth. Well, guess what, guys? That is working great. But check out my coolant here. I'm sucking bottom in there. I got to mix up a little coolant. I'll be right back. Okay, I got some coolant all mixed up now. And if you're wondering, this is what I use on my surface grinder, lathe, and mill. It's called Cool Mist, your pollution solution for the 21st century. Got this off of Amazon. I don't remember now how much it was. I've been working on this gallon for about 2 years now. As you can see, it's 4 ounces to a gallon, and I got about that much left. But maybe in an upcoming video, I'll show you my coolant system too. It's a centralized system. I simply got a bucket sitting back here with a submersible pump in it. Lines run to the surface grinder, the lathe, and the milling machine, and I can turn it on and off at each location. I've got a power switch at each of the 3 machines, and got a flow control valve on each of the 3 machines as well. The only thing I have to be mindful of, if I go over there to the lathe and turn it on, that the valve on the other 2 machines be turned off. So let's drop another thousandths, get some coolant, get some RPMs going, and get some motion on the surface grinder table. I'll show you when we get this done, but it is putting a beautiful surface on there. Beautiful finish on it. I keep walking around looking behind because I'm not sure. I just want to be sure I'm on the right 0 down here on my dial. Seems to be a low corner right at this very front up here. Like maybe a thousandths going in. All right, now I'm going to take a half a thou and feed out just 50 thousandths in each step. Sorry you can't see any sparks. I'm taking that other half a thou now. It's working so good, y'all, I just don't want to quit. I am extremely pleased with that. And I do not see any buildup on the wheel at all. All right, I've got the chamfer block tilted back just a little bit. Hopefully you can see without the shadow in there. But that is a beautiful finish on that. Again, I don't use the word perfect very often at all in my videos, but that's a whole lot closer to perfect than I ever expected. To be honest with you, I had my doubts about surface grinding aluminum, but the wheel on the surface grinder, again, there's no buildup in it. I think that's probably a combination of following Robin's advice as far as at least what the wheel was, the 39C silicon carbide, and keeping it flooded with coolant. So I think that's going to work much better now. It's got a good smooth surface to slide the pieces being chamfered on, and the grooves will give somewhere for the grit to fall into, or at least be brushed into as I'm working. Hope you enjoyed this video. Take care, and expect to see more aluminum surface grinding on this channel. We'll catch you on the next video.